Welcome back to Max with RP. We have been solving problems under differentiation using different rules, chain rule, quotient rule, implicit differentiation process, etc. We'll work out and we will practice some more sums today. If y equal to root of x square plus a square, you have to prove that y dy by dx minus x equal to 0. So you are given y equal to root of x square plus a square. Okay. Now y is equal to, or y square equal to x square plus a square. I am squaring because I am getting rid of the square root. Okay. So I am just squaring on both sides. Now differentiating, I get 2y into dy by dx equal to 2x, derivative of a square is 0. Okay. Now 2 gets cancelled. So dy by dx is equal to x by y, which is same as saying if I cross multiply, I will get which implies y into dy by dx minus x equal to 0. So if y equal to root of x square plus a square, dy by dx into y minus x is equal to 0. Very, very simple. I mean, you can do it by taking the writing it at the power of half, okay, and then differentiating. But easier would be is if I square, because I got rid of the square root. Now look at this. You are given xy equal to 1. You have to prove that dy by dx plus y square equal to 0. Okay, so let us first differentiate x into dy by dx plus y into x equal to 0. Now I can write this as x into dy by dx plus 1 into y equal to 0. The reason for writing this 1 is I want to write y as x, 1 as xy. Because this is not what I want. I want dy by dx to be minus y square. So naturally I need to manipulate this with the given data. So how am I doing that? I have written y as y into 1. Now x into dy by dx plus this 1 I am going to replace by xy. Already there is one y. So x square equal to 0. Now x is common, therefore x into dy by dx plus y square equal to 0. So x is 0 or dy by dx plus y square equal to 0. This is what we wanted to prove. If x is 0, then this becomes meaningless. So this is not possible. So dy by dx plus y square equal to 0 it is what we wanted to prove. Simple problems based on differentiation. Now let's look at this. Y is equal to x plus root of a square plus x square to the power n. This is what is given, right? What is it you have to prove? You have to prove that dy by dx is ny by root of x square plus a square. Okay, so I am going to differentiate this, right? Now dy by dx is equal to When you have x power n, what is the derivative? Nx to the power n minus 1. So n into x plus root of a square plus x square to the power n minus 1 into derivative of what is within the bracket. The derivative of what is in the bracket is 1 plus derivative of x is 1. What is the derivative of root of x square plus x square? Root x means x power half. Root x means x power half. If I differentiate, I'll get f x to the power minus half or 1 by 2 root x. So the derivative of root x is always 1 by 2 root x. Okay. Now this is of the form root x. So what will I get? 1 by 2 into root of a square plus x square into derivative of x. A square is 0, but derivative of x square is 2x. Are you able to follow? I'm applying chain rule here. This is of the form x power n. So when I differentiate x power n, I get nx to the power n minus 1 into derivative of what is within the bracket. Derivative of x is 1. Derivative of root any quantity, root x is 1 by 2 root x. So 1 by 2 root of a square plus x square into derivative of what is within the bracket, right? Differentiate a square, you get 0. If you differentiate x square, you get 2x, and this 2 gets cancelled. So dy by dx is n into x plus root of a square plus x square to the power n minus 1 into, what will I get? If I take LCM as root of a square plus x square, then the numerator, what will I get? Root of a square plus x square plus x. Okay. Now, this is x plus root of a square plus x square to the power n minus 1. This is root of a square plus x square plus x, the same quantity. This is to the power n minus 1 into the same term. So what will I get? N into x plus root of a square plus x square to the power n by root of a square plus x square. Now what is your y? Y is x plus this. So can I write this as n into, so in the left hand side what do I have? Dy by dx. So therefore dy by dx is actually equal to, okay, now this is n and this is y. N y power n by root of a square plus x square into y. Because root of x plus within bracket I have x plus root of a square plus x square. This quantity raised to the power n is y. So I have replaced this with y. N with n. The denominator I have root of a square plus x square. And this is what we wanted to prove. Dy by dx equal to ny by root of x square plus a square. So I first differentiated using the formula x power n. If you differentiate, you get nx power n minus 1. Then because it is a function of this into derivative of this, which is 1 plus 2x by 2 into root of a square plus x square. I have taken LCM. I have multiplied. When I multiply, I get the power n, and this quantity I recognize as y. So x plus root of a square plus x square to the power n, recognize as y, replace it as y, then you get what you need to prove. Now, y equal to log of root x plus 1 by root x. If I simplify this, I will get log of x plus 1 by root x. Okay. Now, this is y. This is y equal to, you all know log of a by b is log a minus log b. So applying the laws of logarithms, I get log of x plus 1 minus log root x. Okay, now I am going to differentiate. So far I have only simplified. Only now I am differentiating. When I differentiate log of x plus 1, I will get 1 by x plus 1 minus 1 by root x. Derivative of log root x is 1 by root x into derivative of root x. What is derivative of root x? Already I showed in the previous problem. Half x to the power minus half 1 by 2 root x. So this is into 1 by 2 root x. Okay. Therefore dy by dx is equal to 1 by x plus 1 minus 1 by 2x. Root x into root x is x, so 2x. So when I take LCM, I'll get 2x into x plus 1, 2x minus of x plus 1. So minus x minus 1. So x minus 1 by 2x into x plus 1. So if y equal to log of root x plus 1 by root x, we have dy by dx equal to x minus 1 by 2x into x plus 1, which is what we needed to prove. Are you all able to follow? Now, your y equal to of log 1 minus cos 2x by 1 plus cos 2x. Given this is what you are given. You have to prove, what is it that you have to prove? Dy by dx is equal to 2 cosecant x. Now, if y equal to half log, when I see this 1 minus cos 2x by 1 plus cos 2x, I recall the formulae of how you can simplify them. What is that formula? 1 minus cos 2x, I can write it as 2 sin square x. 1 plus cos 2x, I can write it as 2 cos square x. So this is y equal to half into log 2 sin square x by 2 cos square x. So y equal to of log tan square x. Now using the law of logarithms, log of a power m is m log a. I can write y as half into log of tan square x is 2 log tan x. I am using the property of logarithms, laws of logarithm. Log of a power m is m log a. So y is simplified to log tan x. Now when I differentiate, I get dy by dx is equal to 1 by tan x. Derivative of log x is 1 by x. So derivative of log tan x is 1 by tan x into derivative of tan x, which is secant square x. So you get secant square x by tan x, which is 1 by secant square x is 1 by cos square x. Then you have cot x, which is cos x by sin x. So you will get 1 by sin x cos x. So what I am going to do, I know 2 sin x cos x is sin 2x. So I am going to multiply and divide by 2. So into 2 into 2. So what will I get? 2 by sine 2x, which is same as 2 cosecant 2x, which is what we wanted to put. 2 cosecant 2x. Are you able to recognize? First I have written 1 minus cos 2x as 2 sin square x, 1 plus cos 2x as 2 cos square x. So this simplifies to tan square x. Then I am using the property of logarithms. Log of a power m is m log a. So log of tan square x is 2 log tan x. So the whole term y gets simplified to log tan x. Now when I differentiate, log of x, if I differentiate, I get 1 by x. So 1 by tan x into, by using chain rule, derivative of tan x is secant square x. Now I have written everything in terms of sine and cos. The whole thing simplifies to 1 by sin x cos x multiplied and divided by 2, because I can write the sin x cos x when multiplied by 2 as sin 2x. 2 by sin 2x is 2 cosecant 2x. Is it clear? Now you have y equal to log of, give your given, log of root of x minus 1 minus root of x plus 1. You have to find dy by dx. Now dy by dx is again of the form log x. Log x, if I differentiate, I get 1 by x. So 1 by root of x minus 1 minus root of x plus 1 into derivative of this. What is derivative of root x? 1 by 2 root x. So 1 by 2 root of x minus 1 minus, what is the derivative of root of x plus 1? 1 by 2 root of x plus 1. So root x derivative is 1 by 2 root x. So root of x minus 1. Derivative of x is 1. So there is no other term. So this is again 1 by 2 into root of x plus 1. This is 1 by root of x minus 1 minus root of x plus 1 into, when I take the LCM, what will I get? 2 root of x minus 1 into root of x plus 1. Okay. So when I take LCM, what will I get? 2 root of x minus 1 is there, so root of x plus 1 minus root of x minus 1. Now what I am going to do, I am going to write this as, this is same as 1 by root of x minus 1 minus root of x plus 1. Okay, here I have root of x minus 1 minus root of x plus 1. Here I have root of x plus 1 minus root of x minus 1. So I can write it as minus of 1 into minus of root of x minus 1 minus root of x plus 1 divided by 2 root of x square minus 1. Within the root a into root b is root ab. So x minus 1 into x plus 1 is 2 root of x square minus 1. Now this term gets cancelled with this term, giving you minus 1 by 2 root of x square minus 1. Very, very simple, straightforward chain rule application. Now, if sin y equal to x into sine of a plus y, then you have to prove that dy by dx is sine square of a plus y by sine a. So what is given? Sin y equal to x into sine of a plus y. To make things simple for me, I am going to write x as sin y by sine of a plus y. Okay, now I am going to find dx by dy. differentiating dx by dy will be equal to, the denominator I will have sine square a plus y. Then the numerator, using quotient rule, sine of a plus y, derivative of sine y is cos y, minus numerator sine y into derivative of the denominator, which is cos of a plus y. Okay, this is of the form sin a cos b minus cos a sin b. So this is sin of, this is a and this is b. Sin a cos b minus cos a sin b. So this is sin of a plus y minus y divided by sin square a plus y. This is sin a by sin square a plus y. Which means dy by dx is equal to sin square a plus y by sin a. This is dx by dy. So dy by dx will be sin square a plus y by sin a, which is what we wanted to prove. Now, you are given x power y. Look at this problem. You are given x power y is equal to e power x minus y. And you have to find dy by dx, and in fact prove that it is equal to log x by 1 plus log x the whole square. So now I am going to take log on both sides. Taking log on both sides, we will get y log x. Log of x power y is y log x is equal to x minus y into log e to the base e. Log e to the base e is 1. So y log x is equal to x minus y. Okay, since I want to find dy by dx, let me collect the terms containing y. So y into log x plus 1 equal to x, or y equal to x by 1 plus log x. So far I have only simplified. I have used logarithms to simplify the given function. And I have now written y as x plus 1 by log x. Now dy by dx will be, now using quotient rule, 1 plus log x the whole square. The numerator 1 plus denominator into derivative of the numerator, which is 1, minus numerator into derivative of the denominator is 1 by x. Derivative of 1 is 0. The derivative of log x is 1 by x. So 1 plus log x minus 1 by 1 plus log x the whole square. So this is log x by 1 plus log x the whole square. This is your dy by dx. And this is what we wanted to prove. Are you all able to follow? So today we have come to the end of the session. We have solved problems based on differentiation using chain rule, using the laws of logarithms, how to solve simple problems and then prove whatever is asked. So if you look at all the sums that we have done today, they involved some kind of some proofs based on differentiation. I hope you enjoyed the session, found it useful. If you found it useful, please do not forget to share it with your friends. Please go through the entire video, practice all these sums on your own, and first And then if you have any difficulty, refer to the video. And I hope you become, really good at problem solving. Wishing you the very best. And until we meet next time, it's goodbye from Revati.